nobody expected that you could find anything decent. And we found another painting which I will explain you later on, which is a very important one, which shows you the life in Dege Monastery in East Tibet. It's a fine painted around 1760. So we were very, very fortunate to find these three objects. And they helped my recovery. Anyway, I will tell you more about this painting later on. So we are still here with Kurt Wüthrich, trying to find three-dimensional structures of proteins. And when you look at the molecule here, and you see the black dots, which are the nuclei, which you want to use as reporters telling you what is going on in the molecule, you have interactions between them. You have interactions through space, you have interactions through the chemical bonding network, and if you can exploit these information, you can determine structures. And that's exactly what we wanted to do. Then one-dimensional spectra are not sufficient. You have here a one-dimensional spectrum along this diagonal, the different peaks here, but you have here cross peaks. And these cross peaks tell you something about spatial neighborhood, about neighborhood within the chemical bonding network, and this gives you the structural information, these off-diagonal peaks. We didn't know how to get this kind of spectra, but 1 year after my nervous breakdown, there was a conference in Baskopolje in Yugoslavia, and I sent one of my students, my first graduate student, to this conference, and then he heard the lecture of Jean Genet, pulse pair technique in high resolution NMR. Nobody knew what he was talking about, but that is Thomas Baumann. He went to that lecture, he listened to Jean Genet, and he brought home his lecture notes. These are the lecture notes which he brought home from that conference. Here they are, neatly written, and we tried to understand what Professor Genet had in mind. And he applied now 2 pulses, not like me, initially just 1 pulse, everything starts to rotate, and you do Fourier transformation. You apply a second pulse a little bit later. And then you get frequencies before the second pulse and after the second pulse. And you try to correlate these frequencies. And you see how the second pulse transforms coherences from one transition into energy level diagram to another transition. That leads to 2-dimensional correlation spectroscopy. You get this kind of 2-dimensional spectra, and from that you can determine the structure. So that was the clue which we learned about at that conference in Baskopolje 1 year after my nervous breakdown. And now you could trace out, for example, here in a protein, you see these are the different residues, alanine, phenylalanine, second phenylalanine, the backbone here. You can trace out the hydrogens here, the NH hydrogens, the alpha hydrogens, the side chain hydrogens, the families of the different protons belonging to one particular amino acid. That's the kind of information which you get out from a cozy spectrum, 2-dimensional correlation spectrum. And then you do, in addition, a 3-pulse experiment. You apply a first pulse, a second pulse, and a third pulse. And between the second and third pulse, you wait. And during this waiting time, relaxation process can occur where a magnetization is being transferred from one nucleus to another one. So you can trace out also spatial neighborhood due to the dipolar interaction between the nuclei. And then you find out who is neighbor of whom. You have here alanine, phenylalanine, and you can now see the neighborhood. And you can put in the street numbers here. You have alanine 4, phenylalanine 5, phenylalanine 6, and you can really make a complete assignment of all the resonances in a spectrum. Here that's what we call a nosy spectrum, which stands for this relaxation effect. And this spectrum has for the first time been recorded by somebody working or having worked today in Bangalore, by Anil Kumar. Anil Kumar was one of my early co-workers, a brilliant co-worker. He went then back to the Indian Institute of Science, continued their work there. He was very important in these early developments. What's that? That's not Anil Kumar. That's a small intermission. I tell you here a story. Namely, on 16th of October 1991, I was flying from Moscow to New York. It's an airplane, it's a Pan Am airplane. And when we were above the clouds of Ireland, suddenly the captain was coming to me and told me, "Richard Ernst, wake up, I have to tell you a news." And I told him, "No, please let me sleep, I'm tired." He said, no, it's important, it's very important. I mean, you just won a prize. And I asked him, which prize? He said, the Nobel Prize. And this was my reaction, wow! So the plane didn't explode, but I was in an excited state, and I was coming slowly down. And then after my coming down, I had to go to the cockpit to talk with the committee in Stockholm, and they told me, yeah, it's true, you won the Nobel Prize. Anyway, then the journalists were calling me, asking me, what are you doing now with all the money which you just won 5 minutes ago? I told them, I don't know yet. But anyway, at the same time, in Zurich, they organized a party. I was still in the air. That is the vice president of our school, Mr. Sharma of Zurich. This is the communication manager. He establishes the connection to the plane, and he is congratulating me for my success. And somebody had to explain in front of TV, what is NMR? And that was my wife who had to do it. So she learned in the meantime a lot of NMR also, and my son, he was checking on her that she didn't make any errors. So that was this happy event in Zurich. And you can imagine, I was sitting still in the airplane. Nobody was bothering me. The TV was just, the movie was just running in the plane, and I had a quiet time there. And that's what happens when you have won a big prize. It's very easy to make girlfriends. And they all liked me, and I liked them. And it was really very nice. And unfortunately, that doesn't happen again in my life. But this moment I enjoyed very much. And then, a little bit later, I had to fly to Stockholm. Then came here the meeting with the defendants, with the judges here, and I got my sentence here. My sentence was, lifelong, for his contributions to the development of high-resolution NMR spectroscopy. It was the very first time I was shaking hands with a king. And you know what you do when you shake hands with a famous person. You don't wash your hand anymore for a few weeks, perhaps even years. You keep it in your pocket that nobody touches it. But I mean, the king didn't impress me very much. The handshake which I really can't forget is this handshake. It's the most charming queen. And she was really sweet. She was really sweet, and I was pressing her hand for a long time. I pressed it hard. And she didn't scream, no, but afterwards she told me, next time be more honest. And the king agreed, and my wife agreed, and I felt a little bit ashamed. That's what can happen. Anyway, afterwards then came the big dinner in the city hall in Stockholm. The king here. No, that's not the queen, that's my wife. And they are talking together. They are laughing together. They are talking together. And on the other side of the table, this most charming queen here from the backside. And who